Hello and welcome back. Again, a bit of a interlude between uploading videos. Sorry about that, life gets in the way, you know how it is. Anywho, today on the bench we've got 4 of these Mullard XG1-2500 mercury vapor Thyratrons. Interesting looking beasts, aren't they? Big old beasties too. These things are capable of switching. Basically they're just an equivalent, the valve equivalent of an SCR, silicon rectified diode. Rectifier? No, silicon controlled rectifier, yeah. Rectifiers, yeah. But the only difference is they're like a triode, they've got a grid, but instead of with a triode you can sort of, you know, use them as amplifiers. These you can't, they're just switches. In a nutshell, they can do 1000 volts at 15 amp. I mean, that's pretty good going, isn't it? As you can see, we've got 4 pins on the bottom, top cap. 2 of those are heaters. These are directly heated so that the filament and the cathode are all part of the same thing. We've got a control grid, as I said, anode, and that's it. And we've got one here in our test setup. So without further ado, let's go and power the bugger up. Okay, are we ready? So that's the heater on, and you should start to see that if I zoom you in a bit. Got you on a tripod now, no wobble cam. Right, so then if you can just see a little bit of a glow down there. Turn the back. Right, now I'm going to turn the high voltage up. And I've also got this limited to 1 amp. Otherwise it'll just... Right, I've set that to 300 volts. And current limited it to 1 amp. Now I'm going to reduce the voltage on the grid. Like a normal triode, the more positive you make the grid, the more current flows. But unlike a triode, this is just on or off. You can't like turn the grid more positive and then negative to turn it off. This is just either off or on. So here we go. You ready? 25 volts, or should I say negative 25 volts. Negative 20 volts. Negative 15 volts. Negative 10 volts. Negative 5 volts. 5, 4, 3, 2. Right, that's our big power supply going into current limiting. As you can see, that is 1 amp. And it glows rather prettily. A sort of blue colour. I think if we fed it a lot more voltage we might get it to go a bit brighter, but I've got to watch our load. Right, now to get that off, I mean, if I reduce the grid voltage, right? Make it more negative, in other words. 10 volts, minus 10, minus 15, minus 20, minus 30, still staying on. So basically I've got to really knock this off quick. Right, that's the power supply. Right, I can smell that big power resistor starting to oh, you fucker. That is well hot, and it's starting to niff a bit. So oh yeah, let's turn the heater off. As you can see, they just act like a switch. the grid doesn't do anything with it on DC. So next what we're going to do, we're going to connect a couple up and see if we can rectify, use them as rectifiers, you know, in a power supply. But we're going to see if we connect them to a transformer with AC on the anode, whether we can turn them off, whether we can regulate the diodes by altering the grid voltage. Right, well, as you can see, things have got a bit more complex, a lot more complex, although it's not that complex, it just looks like it. Right, where to start? Right, where was I? Originally I had this sort of idea. Just point you over here. Oh, okay. It's hard to put you down anywhere. Just go over here, look. So my original idea, so here's your transformer. This is our high voltage transformer. Centre tap to ground, and then we've got, these are the mercury vapor Thyratrons. Anode, so basically on the positive going AC cycle, that'll let it through, so it's rectifying it, yeah? The two cathodes are tied together, so we've got basically a positive voltage coming out. That is a ground, and obviously we're sort of grounded here. We've got a capacitor. This was a simple setup that I tried. And then I had a DC power supply, as before, one side grounded and the negative going to both grids. That didn't work, obviously, because before the cathode was grounded, right, 0 volts, and so it was easy to make the grids negative. But in this case now the cathodes are at whatever, say plus 100 volts. So now we need to make our grids, let's say they triggered at negative 2 volts before. If our cathodes are at 100 volts, plus 100 volts, therefore we need to make our grids plus 98 volts. Are you with me? That didn't work. So next, I had a look online. There's not a lot online, although I have found a few sources and I'm wading through it at the moment. The nearest thing to a simple Thyratron power supply that I could find is the one that Curious Mark and Ken Sheriff, I think it is, covered. And this is basically a copy of that, but we've got different Thyratrons, hence the problem. So basically I just used their control circuit, which is here. Hope you can follow this. So the other thing I've got in there is a couple of RF chokes. I'm not quite sure what they do. Obviously stop it oscillating, probably. So with basically what happens is you've got a positive voltage, you run it through a voltage divider that controls the grid of the 6V6. The cathode of the 6V6 is held at, I don't know, usually a neon is about 90 volts, but we're not getting a lot of voltage out. So let's say it's 50 volts above ground, blah blah blah. So by controlling this voltage divider, so this is a 10k pot in the middle there, we can alter the bias of the Thyratrons. Now, a paper I read, there's various ways of controlling Thyratrons in an AC circuit. There's vertical, horizontal and something or other. And in that it mentioned that basically you've got a DC bias, but it's got an AC sort of sinusoid or chopped off AC go into the grids of these Thyratrons. I can't see any AC going to there, and I can't see, I don't know how that would work. But then again, I haven't got the circuit wired exactly as they have. So, with all that waffle aside, as you can see, the Thyratrons aren't glowing. They are working though, somehow, because we've got 182 volts across our couple of capacitors. All these capacitors aren't wired in, this is just an old power supply sort of thing that I've just popped in. We've got a choke going from a centre tap to ground, but if you look, this is our, this is not, obviously we haven't got DC here, and I've got a times 10 probe on there. If I stick that on AC, will it tell me? Yeah, 200 odd millivolts of ripple. Well, I think there's more than that, but if you look, when I first powered this up, we just had a normal sawtooth ripple, and now we've got sort of craziness going. But you can't really see that because of the camera, but it's not steady. But this does work. If I alter this trim pot, sorry, it's late in the day, my brain's going. Pretend pot. If I alter this pot, it does. See if you can see that. It does have an effect, look. Now, that's what I had before, look. A sawtooth. Times 10 probe, yeah, so that's right, 200 millivolts ripple. Right, 20 millivolts per div, times 10 probe, 200 millivolts ripple. Could probably get that down by bunging more capacitance at it. So it does work. It's a bit later on now, end of the day, I've about had enough now. What I've done, I've changed the HT transformer for a 800 volt one. Just got the heaters warming up. Right, so we flick, got the, right, that's our high voltage on. Whoa, what's going off? We got, yeah, it's sort of, hang on, let's crank the bugger up. Yeah, it's whacking. So we've got a high voltage transformer, but it's not as high a current. Right, just put the load on. Yeah, as you can see, we've got a bit of glow on one. Yeah, it's not perfect. We need a better high voltage transformer. I mean, really, I mean, we just build the bugger with silicon S, you know, triax. What we want is a nice pretty blue glow. Right, I'm going to turn that off. So, watch where I put my bloody fingers, is high voltage everywhere. So I've been through all my transformer stash. Even I've been all over. I haven't got a really decent high voltage, high current transformer, but I did find. Where is the bugger? Here. You swine. Right, I did find that. That's for a stereo Dynaco ST70. So we'll give that a try tomorrow. That should be good for what? 300 volts, couple of 100 milliamps at least. So we'll give that a go, and we'll try and get it so they're glowing really nice and pretty blue. we'll try and get it so that it's going really nice, you know, and blue. I've got some decent voltage, because I think this is the problem. Right, that's enough waffle for now. Try and get this uploaded tonight, so you've got something to watch on Christmas Day. Sorry it's not much to watch. You know, we could be better, but yeah, sorry about that. Bloody memory ran out. Right, there I am, editing it. I'm going to try and get this uploaded tonight for you to watch on Christmas Day. Sorry it's not much. Usual typical video quality and crap sort of editing and what have you, but hey, it's Christmas. That was evidenced by the old tree there and the old fire, which needs some more wood on it. So without further ado, wishing you all a happy Christmas, happy solstice, happy Yule, happy whatever. Have a good one, as best you can anyway in these interesting times. Take care of yourselves, hopefully catch you soon rather than later, and yeah, have a good one. Ta-ra for now.